This video is brought to you by Altium 365, where the world designs electronics, and Octopart, the fastest search engine for electronic parts.
Get a free copy of Altium software using the link provided in this video description. Plus, when you sign up for an Altium Designer free trial, you will get Altium 365 and 25% off discount. Hi, and welcome again to another video. Today, we're gonna learn to design a DC-to-DC converter circuit that uses MAX1709 series IC. So basically, it is a step-up conversion system that originally made by Electronic Circuits. So let's go to the Altium. So first, you need to have a PCB project file. In order to have a PCB project file, just click on File, New, then Project. Then the Create Project dialog box will appear. Now you can set here the project name and the folder in where you want to save your project. For this case, let's put here Step Up DC-to-DC Converter using MAX1709 for the project name. Then click Create. After that, we need to create also the schematic doc. Click again on File, New, then Schematic. Then save this one. Next is for the library. Click again for File, New, Library, then Schematic Library. Go back again to the project. Then let's create PCB library. Click on File, New, Library, then PCB library. Save again this one. Now that we have a schematic doc and the PCB library and schematic library, we can start the schematic. Now for this project, we will be using a library loader. So this is the version I am using, version 2.2, and the manufacturer part number of each component will be pasted here at the search bar and it will automatically load in the schematic sheet. So this is the BOM list for this project. And we're just gonna copy the manufacturer part number of each component to the library loader. So let's try this one. Copy the part number of this capacitor. Go back again to the software and click on the loader. Paste at the search bar. Paste the part number in the search bar, then click on search. Wait for it to load. Now click on the result, then click Add to Design. Now as you can see, it automatically loads in the schematic sheet. But we will need to change the parameter of this capacitor so it is readable in the schematic. Let's go back again to the schematic library. Click on Schematic Library panel, then click on the added component. Since this is 150 microfarad, we can put here in the comment the exact value of this library. So for this case, let's put 150 microfarad and the package. So let's save this one. Go back again to the schematic library. And now, here's the difference of original loaded library versus the edited one. Now repeat the same process in other components in the BOM list in order to complete all the library. After you finish all the library in the BOM list, now you can see in the schematic library panel all the libraries added using the library loader. So go back again to the schematic doc and click on Components. Now you can see, here's the complete components that we need to add in the schematic sheet. So in order to add it in the schematic sheet, just drag the components inside the schematic sheet. Now after you added all the components in the schematic sheet, next we're going to assign the designator of each component. We can set it manually by double-clicking the components and its properties will open, and we can set here manually the designator. Or we can also use the annotation. Click on Tools, Annotation, Annotate Schematics, and just click Update Changes List. Now, as you can see in the proposed column, the tool will automatically assign designator on each component. So just click Accept Changes, Create ECO, then click on Execute Changes. Now, as you can see, the designator of each component is automatically assigned. Since this is a small circuit, we need to adjust the size of the schematic sheet. In order to do that, click on the Properties panel, click on Custom. Now here you can set the width and the height of the schematic sheet. Now we can start connecting the components. So to connect each component, we need to place a wire. Click on Place, then Wire. Now click on the pins of each component and snap it to the other component in where it should be connected. After we connect the components, we will need to add a power port. Click on Place, then Power Port. Now press Tab on your keyboard to access the properties and change the style into the power ground. Now snap it to the required connection. Now we're done with the schematic. Next thing we're gonna do is to put all the components in the schematic in our PCB. We will need first to create a PCB dock. Click on File, New, then PCB. Then save the created PCB. Go back again to the schematic dock. Now it is important to perform validation before ECO. Right-click on the project file and click Validate. Then check on the message if there are errors found. Once the results are clear, click on Design, then Update PCB document. Now the engineering change order dialog box will appear. So just click Execute Changes. Now you can see all the components are added in the PCB. And now we can start with the placement. So just drag the components inside the PCB . And after we finish the placement of all the components, now we will need to set the board shape. In order to set the board shape, press 1 on your keyboard to activate this kind of view, then click on Design, then Edit Board Shape. Now you can see some points appear, and we will just manually drag it based on the desired board shape. Now, press number 2 on your keyboard to activate the 2D view. Now that we're done with the placement, we can now start with the layout. So to add a connection on each component, click on Route, then Interactive Routing. Click on the pads and connect it to the other end of the pad in where it should be connected. Now we're done with the layout. As you can see, the remaining unrouted nets are the ground nets. So we don't need to route it using a trace or line. We will use a polygon pour. To place a polygon pour, just click on Place, then Polygon Pour. Then snap it to the edge of the board. Then we can set the parameters of this polygon. In this case, let's change the net into ground. Replace the name by ground as well, then make sure that you click solid. Then after that, to see the changes, click on Tools, Polygon Pours, and Repour All. As you can see, the ground net has been poured by the polygon. Now to view it in 3D view, just press 3 on your keyboard, and now we're done with the PCB design. So that's all, and I hope you learned something from this video.